Hello friends, welcome to Learning. My name is Dr. Ben. Today we are going to learn some awesome stuff. Learning is for everyone. Let's make it fun and let's enjoy. Hello and welcome back to the Excel 2019 Using Formulas and Functions learning series. Today we will discuss using references in formulas. If you are enjoying the series, click the like button below and also click the subscribe button to receive notifications of new lessons and modules. Let's get started. What are our learning objectives for today? At the end of this module, you will be able to apply relative and absolute references in a formula, apply mixed references in a formula, use named ranges in a formula, and use named worksheet references in a formula. In our past module, we discussed that a cell reference identifies the coordinates of a cell based upon the column letter and the row number. Example, this is a column, A1, and 1 is the number, the row number. To provide more flexibility in our worksheets, we typically use the cell reference versus hard-coding constant values when creating a formula in Excel. If you notice here in my formula box here, or cell C1, I type in the hard numbers 2 plus 2 equals 4, referring to A and B over here. This is fine and dandy, but guess what? It's going to get me in trouble. The benefit of using a cell reference is that when I copy the formula to a new location, the cell references automatically updates. However, there may be times that you need the formula to always refer to a specific cell, regardless of where the formula is copied in the worksheet. To ensure that our formulas calculate as intended, it is important to understand the concepts of relative, absolute, and mixed cell references. Let's discuss using the relative cell reference. I'm going to delete this hard coding here so it won't get us in trouble. As you copy a formula from one location to another in a worksheet, you will notice that by default the formula references or reference changes based upon where you copy the formula. What actually is copied is related to the pattern of the formula as opposed to the specific references in the formula. This is called relative cell reference. Let me repeat that. So what is copied is related to the pattern of the formula as opposed to the specific references in the formula. Relative cell referencing. Now please note, the definition of the word pattern used here can be interpreted as something that is predictable or a repeating arrangement of numbers or shapes, colors, or objects, and that follows a specific rule. For example, a pattern could be the numbers 5, 10, 15, 20. The rule, add 5, 10, 15, 20. So to carry out this pattern as an example, let's take a cell C1 here once again. And I'm going to create a formula in here. The formula I'm going to create is going to be equal sum. We're using our tab key to get over there. And we're going to copy over or add the A1 plus the B1 together. Hitting our return key, we come up with the sum of 4, which is appropriate. Notice that now my formula says what? Equal sum A1 to B1, A plus B1. I'm going to copy this into another cell. Now watch what happens. Control V, I copy that formula, hitting my escape key to get out of this marching ants as we called earlier. The formula has been copied to cell I1. Notice that the formula is now G1 to H1. Notice the specific pattern. This is G1 and H1. They're juxtaposed right here. They're together, side by side. The same here. This pattern, A1, B1, they're side by side. G1, H1, they're side by side, giving me the result set here. Let's say 5, 5 is 10. So notice that when you use the relative cell referencing, it copies over the patterns here in from the formula. I can then take this again, this same formula, and copy it over here. I should have that's correct, M8 and N8 based on the patterns that you see here that you copied earlier. That is called cell referencing. And it's best to use cell referencing versus the hard coding, because I can get into serious trouble here by hard coding this and trying to copy it somewhere else and forget that that function or that formula is actually somewhere else. Let me erase all of this here. There may be circumstances where you do not want a cell reference to change when it's moved or copied. An absolute cell reference refers to a formula that contains a specific cell or range of cells that do not change regardless of where the formula is copied or moved to. To specify an absolute cell reference in a formula, use the $ before the column and the row of the cell you want to reference. Let's take a look at this. Absolute cell referencing right here. I'd like for you to note, as you create a formula using cell references, you can toggle between the relative, absolute, and mixed references by pressing function F4, and I'll go over that shortly. So look at this here. We have in our worksheet here the month and the quarters. I am adding a bonus amount here to the actual totals right here. So my sum is, or my formula is equal B6, which is down here, 10%, B6 times E2. I am multiplying the 10% times the total number of the quarters in the month of January. I want this number here to be constant. I don't want it to moving around. So what do? I put in my $, as we said earlier. To specify an absolute cell reference, which is going to be absolute cells B6, I'm going to put the $ before the column and the row of the cell I want to reference. I'm referencing B6. I don't want that to change. That's my absolute. Notice below. Again, see that E3? See that E4? The rows here have changed, but my column did not. And that's what you want. So once again, absolute cell references. An absolute cell reference refers to a formula that contains a specific cell or range of cells that do not change regardless where the formula is copied or moved to. Let's go ahead and create the formula using absolute cell referencing. I'm going to take my mouse and place my mouse in the cursor into F2. In F2, I will create my formula for absolute cell referencing. I'm going to calculate B6 times E2. That is the 10% times the total 600 for January. Creating my formula, equal, open parentheses, taking my cursor, placing it onto the B6, selecting it, and using my function key to create my $ to keep it constant. Function F4 gives me the $ for both the row and the column, or column and row, B6. I want that for both. If you want to toggle through, you can do that too. Toggle through, it gives me the $ for the 6. Toggle again, $ for the B, which is the actual column itself. But I want it for both column and the row, B6. Use my multiplication symbol, times, and I'm going to select my column B2, or E2 that is. Closing the parentheses, clicking return, and there it is, my 60. So 10% times 600 is 60. I'm going to take this cursor of mine onto, there we go, the handle here, dragging it down. There we go. I now have the formulas for F2, which is the column B6 times E2. Next one, B6 times E3. Next, B6 times E4. Notice that my columns has not changed that I wanted there. I did not want my cell range or cell to change at all. Regardless of where the formula is, it did not change. But the only thing that has changed here is the row, which I want changed. This is absolute cell referencing. Let's take a look at the mixed cell references. Mixed cell references. There may be instances when you need to copy a formula, but the formula must only change the row reference and keep the column reference the same. In this case, you will configure the column reference and the row number with the absolute reference indicator, the $sign. This type of cell referencing combines both relative and absolute elements and is called a mixed cell reference. For example, take a look at the multiplication table on your screen. We can use the mixed reference to multiply the numbers. In this table, mixed cell referencing allows us to build only one formula and copy it across the entire grid, locking in the column for the row values, such as A3 here, right here, the column for the row values, A3, and locking in the row for the column headers, B2, so that each cell correctly multiplies its corresponding row numbers by its column number. By doing so, the formula efficiently creates the entire table without rewriting formulas. Let's take a look at this. I'm going to go over here to my B3 and create the formula. I'm going to create my formula by placing equal sign, open parentheses. I want to copy in A3. That's the column A3. There's going to be A3 1 times B2. I want to lock in my column by selecting function F4. There's my $signs, but I want the $sign just for the column at this point. I'm going to toggle through and select only the A. There we go. My $signs is affixed on the A only. Continuing on, A3 times B2. It's right here, B2. Now here, I only want what? The row. So I'm going to go back and do my function F4, and the row should be the 2. There we go. Closing that parentheses, hitting enter. Looking at my formula again, $sign A3 times B, $sign 2. The column will stay the same, but the row will change. Taking my cursor, clicking on my handle, dragging it across, and voila, we now have the A3 times C2, the A3 times C D2, and so on. Notice that my column is constant and my row is changing. So I want to do this now for the entire grid here. Taking my cursor on the handle again, absolutely not. Highlighting all of that. Coming down. There we go. Notice that now every item is aligned appropriately. Let's say 7 times 7. Right here, 7 times 1. We have A9 times B2, which we wanted. A9, which is 7 times C2, which is the 2, is 14, and so on. Those are correct. So what we have here is our mixed cell referencing, where the formula only changes the row reference and keep the column references the same. Change the row referencing right here, the rows, and the columns are the same. If I didn't have that, what would happen? Let's go back up here and let's say, escape out of that, escape out of that. I'm going to take that $ away from the row 2. Return key. Okay. 1 times 1 is 1. Move it all across. Copy it. So far we're doing pretty good. Okay. It's giving me the numbers I want. But guess what? If I continue on, copy this across all cells. Look at that. I get a bunch of garbage here. So apparently, this cell here is not constant on the B2 side. Look what happens. On cell 7, let's see, A7 times D7 is giving me D6. So apparently, this is not giving me the correct columns that I want and rows that I want actually to multiply. So you always want to use the mixed cell referencing when you want to change the row reference, which is not changing here, and keep the column the same. Going back here. Oops. I'm going to delete this. There we go. Now I want to take this and add in the correct value. A3 times B2, great. Move it across and bring it down. We're back at the correct numbers here by looking at the $ on our column and the $ on our row, which gives us the mixed cell referencing we wanted, and it's changing the rows but keeping the columns static. Let's reiterate. Mixed cell referencing helps you lock either the column or the row in a formula so that when you copy or drag it across the cells, parts of the reference stays fixed while the other part automatically updates, as you see here. In Lesson 4, Module 2, I discussed and demonstrated naming ranges. As you might recall, a named range can either be a single cell or a group of cells with a designated name. For example, in our worksheet named ranges, let's take a look at the cell B6, 10%. This cell has been named by looking at the name box here. It is called bonus. Using a named range in a worksheet provides multiple benefits. For a larger worksheet, a named range can be used as a type of bookmark, which then enables you to quickly navigate to the location that has been named. For formulas, a named range enables you to assign meaningful names to cells or a group of cells, which can be used in place of the column and the row references, as demonstrated here in this worksheet. The named range can also be assigned a scope to be used within a specific worksheet or even be referred to from multiple worksheets within the entire workbook. Now take a look at this name range again here, B6 in bonus. This named cell is used in the formula for F2, F3, and F4. In the formula bar up here, notice that equal bonus times E2 is displayed. Using the name bonus is so much easier to remember than referring to cell B6 when you reference this location in formulas. Let's take a look at the named ranges worksheet number 2. When you use a named range in a formula, it is treated as an absolute reference. After you have defined your named ranges in a workbook, you can then reference the stored names as you input a formula into the worksheet or the cell itself. To reference a range name, begin the formula with an equal sign. Let's go ahead and do that. We're going to type an equal sign here, and from there, we can simply enter the name of the reference to be added to the formula. The named range we saw earlier was named bonus. As we begin to type the word bonus, notice that the IntelliSense automatically suggests stored names based upon the characters inputted. I inputted BO and it brings up bonus. Let's go ahead and select that or type the entire word bonus. I'm going to go ahead and tab here. From there, I can then finish my formula. There we go. Our formula reads equals bonus, which is 10%, times E2, which is the 600 for the month of January. I can then click on the cell again, take my handle and dragging the formula down all through these cells. And there we have it. Another method used to add a name range to a formula is to select the Use in Formula option in the Defined Names group ribbon. That's called again the Use in Formula options found in the Defined Names group ribbon. Let's see if we can find that. We're going to go to the Data or Formulas tab, actually. In the Defined Names categories, Using Formula, click the down arrow. Here's the name, bonus. I'm going to delete this real quick here. Using Formula, click the name bonus. It provides the equal sign for us and the word bonus. All I need to do is put in the multiplication sign and then select my cell and hit enter. Let's take a look at something that is going to be very beneficial for us as we use our defined names. In the Use in Formula area drop-down box, click on Paste Names. There we go. The Paste Names options is used to create a list of names and cell references stored in the workbook. This information can be used as a guide to show reviewers each of the defined name ranges and their associated cell ranges. If I were to go ahead and click here or click Paste List, look what happens down here. It gives me that list of the defined names and their locations. This comes in great handy when you are taking on different tasks in your worksheet or workbooks and you remember the names of the different commands that you want to use. They're right here in this Use in Formula, Paste Names dialog box. Not only do we have cell references, we also have worksheet and workbook references to also be used in a formula. A worksheet reference refers to a cell, range of cells, or named range located in another worksheet. You might use worksheet references whenever you need to create formulas that reference data throughout multiple worksheets. For example, one worksheet may display a summary of data based upon information located in other worksheets within the workbook. Here's what I'm talking about. My boss, as you see here, my boss wants the numbers for January totals, February totals, and March totals from a certain worksheet. I'm going to go to that worksheet and show you. In the named ranges, we're talking about these totals here. He wants those on a separate sheet. I'm going to go back to my worksheet itself, right there. I'm going to bring in those numbers from that other worksheet. By going to my cell, D4, I'm going to type in an equal sign, go to the worksheet, which is named ranges, and click on totals for January. Notice in my formula bar, I have a name ranges equal sign, equal name ranges, and E2. Clicking enter on your keyboard or return key, it gives me those numbers in that cell that I had initially highlighted. Clicking back in there, it's showing me in the formula bar, I have a sheet name and the cell address. Remember, the sheet name refers to the name of the sheet that contains the data. The cell address refers to the column and row reference that contains the data. Let's go back and take a look at the February totals. I'm going to click in here, an equal sign, go to that worksheet, named ranges, clicking February totals in that cell, and return key. Again, I have 800 that's coming from a sheet called named ranges, followed by the cell address. Last time for March, my equal sign, selecting my worksheet, and enter. Again, we have the name of our sheet and our cell address. You can also reference data from another workbook, not just a worksheet, another workbook entirely, by including the name of the workbook in square brackets. Now, when you reference another workbook, that workbook must be open. Let's just take a look at that real quick and see what it looks like. So here we have a worksheet for some information for my boss once again. He wants to see the business unit advertising and software and their sales account data for January for the year 2012 and 2013. Now, this particular worksheet I'm going to is filtered with or peppered with so much data, you don't want him to see that worksheet. You want to just extract information from there. What we're going to do is extract the business unit advertising and software data for the two particular years. How do we do that? I'm going to click into my January E2, here we go, E2 cell, put in my equal sign, go to the spreadsheet that must be open, or the workbook that must be open, and extract that data. Here we go. Look at this. You do not want your boss seeing all of this, just portions of this. I want to get the sales, the advertising business unit sales data for 2012 January. Click in there and see the marching ants appear. Hit your enter sign or return key on your keyboard and it brings up the data right there for you. I'm going to do the same thing for software for 2013. Bring it up and here it is. 2013 sales software for January. Now take a look at these two. In the advertising, the difference you have here in your formula bar, once again, we have the information for the formula. We have the reference data, which includes in square brackets the name of the workbook. In square brackets beginning, square brackets ending, followed by the name of the worksheet. The worksheet name is financials, followed by, once again, the cell address. And notice that the cell address here has the absolute values or the absolute cell references wrapped around it. Let's go back to that worksheet again in the other workbook. Taking a look at that data. Notice it has the data there in F11. There we go. Going back to our regular workbook that we're working in. It's F11. And notice it brings in the cell referencing right here. We have learned a great deal from this module. It is now time for a knowledge check. Attempt to answer the questions presented. You may pause the video after each question to review. Return to the lesson when you are ready. The answers to each question will be displayed a few seconds after the reading of the question and possible answers. Let's begin. True or false? In Excel, the benefit of using a cell reference is that when you copy the formula to a new location, the cell reference automatically updates. A. True. B. False. The answer is A. True. True or false? In Excel, to specify an absolute cell reference in a formula, use the question mark sign before the column and the row of the cell you want to reference. A. True. B. False. The answer is B. False. You must use the $sign before the column and the row of the cell you want to reference. What did we learn from this module? We learned how to apply relative and absolute references in a formula, apply mixed references in a formula, use named ranges in a formula, and use name worksheet references in a formula. This is the end of Module 2. Stay tuned for Module 3, Introduction to Functions. Thank you so much for your time. Have a great day. Goodbye.